So, this is a guided reading of a National Geographic article, which I've picked out. It's the first vaccine. I think it's quite good for the time we are living in right now. It's very topical. It relates to what's going on in the world right now. So, this is going to be about the vaccine. I'm just going to read it, maybe summarize some points, and then maybe ask some questions that you can think about. So here we go. Vaccine, a great medical victory. From the bubonic plague to influenza, history is rife with tragic tales of disease devastating defenseless populations in every part of the world. Then, an 18th century English doctor found a simple way to prevent smallpox and save millions of lives. Infectious diseases are still headline news, but modern medicine has made it easy to forget the terrifying frequency and rapidity with which epidemics wiped out populations in the past. Poor medical understanding made it seem like disease could break out anywhere, at any time, and no one was safe. Death would sweep inexorably through communities with little explanation for an apparently random choice of victims. Of all the many diseases that have scourged humankind, smallpox was one of the deadliest and most feared. For so much of our history, so many have lived and died in its shadow, that finding a way to prevent smallpox was a turning point for humanity. That's a great sentence there. Much of history, so many have lived and died in its shadow. So it's kind of looming over everybody. It's just always there, and you are in its shadow. This scientific milestone was achieved toward the end of the 18th century by Edward Jenner, the English country doctor who created the smallpox vaccine. Remarkable though Jenner's discovery was, it did not occur in a vacuum. So remarkable though Jenner's discovery was, it did not occur in a vacuum. It did not occur in a vacuum means he didn't just do it by himself. He didn't just sit in his laboratory and crank out ideas and vaccines and test them and it all worked. It did not happen in a vacuum. There was a long tradition of medicine behind him that he was working with, and he was using research from other people, and people were working together. So Jenner developed his vaccine on the foundations of a long struggle against smallpox and a particular technique commonly used in Turkey. In 1716, Lord Montagu arrived in Istanbul to take up his post as the new British ambassador to Turkey. His wife, Lady Mary Wortley Montagu, had been struck down with smallpox just 2 years earlier. Somehow she had survived. She had survived, but had been left disfigured by the disease. Good use of past perfect tense there. Lady Montagu mastered the local language and befriended Turkish women, through whom she made an extraordinary discovery. Her new friends, defying logic, would deliberately infect themselves and their children with pus from smallpox sufferers. Now, pus is a little gross. Pus is the liquid that comes out of a wound. If you have it on your skin, sometimes some liquid will come out, and it's not blood. It's just kind of sometimes it's yellow and thick. Anyways, pus. Then they suffered a mild bout of the disease. So they would infect themselves with the pus, after which they were left immune to its deadly effects. Lady Montagu was deeply impressed. She was a highly independent woman who had already taught herself Greek, Latin, and French, and who had married against the wishes of her parents. Without hesitation, Lady Montagu inoculated her own children. That means you inoculate someone, it's like you protect them from a disease. You vaccinate them, declaring, "I am patriot enough to take pains to bring this useful invention into fashion in England." So she's patriot enough to suffer and use the invention and bring it into England. Bring it into fashion, make it trendy. Such methods were, in fact, already used in Europe, but Lady Montagu Edward's great achievement was to publicize the technique known as variolation, and to energetically defend it against the entrenched hostility of some doctors and even priests. Thanks to her campaign, a number of high-profile personalities inoculated themselves using the Turkish method, among them the kings of Denmark and Sweden and the Russian Empress Catherine the Great. However, variolation had a serious shortcoming. Between 1 and 3% of those inoculated fell ill and died. This mortality rate explains why the procedure never became a fully established practice. Lady Montagu, who had done so much to fight smallpox, died of cancer in 1762. It was the year that Edward Jenner, the man who would strike the decisive blow to eliminate smallpox, turned 13. So that is a lot of interesting information there. She was using this for a long time. It was effective, but the death rate was too high. So where is that? 1 and 3%. 1 and 3%. That's too high for people. So they don't really like it, but this is now Edward Jenner is coming of age. He is 13, and he's going to maybe build upon this technique. So before Jenner, at least 5 doctors had carried out research into vaccination before Jenner. During a smallpox epidemic in 1774, English farmer Benjamin Jesty used the cowpox virus to successfully inoculate his wife, but did not make his experiment public. Okay. The Good Doctor. Let's just actually go here. Smallpox, a disease defying borders. So, smallpox was one of the deadliest diseases in Europe during the period before the French Revolution. At one point, some 80% of the total population were struck down with the standard strain of smallpox. A third of those infected died. Although hemorrhagic smallpox affected a much smaller proportion of the population, its mortality rate was nearly 100%, since the inhabitants of Europe at the time were descendants of generations of people who had survived smallpox. The population there had a certain degree of immunity. However, when the dreaded pestilence was exported to areas that had never experienced it before, such as Siberia, the Pacific Islands, or the Americas, entire communities were wiped out. With its capacity to spread, smallpox was one of the most devastating consequences of Europe's colonial expansion. So when the dreaded pestilence, I think it's pestilence, I think that's the pronunciation, was exported, so the dreaded bacteria, the dreaded virus, the dreaded bad thing was exported where they had never experienced it before, it was really bad. Devastating consequences, and that's just another effect of Europe's colonial expansion. Okay, the Good Doctor. Edward Jenner was born the son of a country vicar in the English village of Berkeley, Gloucestershire. I think that's how you say it, sorry. When he was 5, his mother died in childbirth. His father died 2 months later. Young Edward went to live with his brother. Okay, so first we have the house in Berkeley, where Edward Jenner was born. Jenner lived and practiced medicine in this area of rural England for much of his life. Very nice house. Symptoms of doom. Smallpox manifested itself some 12 days after infection. The victim would start to experience muscular pain, acute general discomfort, and fever as high as 104 degrees Fahrenheit. On the 3rd day, a rash would appear in the mouth and on the tongue, spreading to the rest of the body. The pustules that would cause death by blood poisoning, secondary infection, or internal bleeding appeared on the 6th day. On survivors, the scabs left behind by the pustules would peel off, often leaving the skin badly pocked and disfigured. Okay. So, He was later apprenticed to a surgeon, studying and practicing medicine in a hospital. As a member of a local medical association, he published detailed papers on a wide range of medical conditions. He also wrote on a number of other topics that interested him, such as ornithology and aerostatic balloons. In 1789, his brilliant research on cuckoos won him a fellowship with Britain's most prestigious academic elite, the Royal Society. Away from birds and balloons, Jenner spent the 1790s methodically searching for a way to protect humanity from the disease that so blighted his country. He believed that something more effective than variolation was needed, and something with fewer risks for the patient. Earlier scientists had suggested that cowpox, a mild variant of smallpox found in cattle, might offer some kind of solution. As a doctor with a rural practice, Jenner was in an ideal position to research cowpox and its effects on people who worked with cattle. Jenner observed that milkmaids would often contract cowpox after coming into contact with the pustules on cows' udders. So we get it from the cows. During smallpox outbreaks, milkmaids' families would fall ill, but the milkmaids themselves, if they had had cowpox, were spared. If they had had cowpox, they were spared. Okay. On May 14, 1796, Jenner took the bold step that would change medical science. He extracted pus from the sores of a milkmaid and used it to inoculate a little boy, the son of his gardener. A week later, the boy fell ill. For a tense couple of days, Jenner monitored his progress, and then the boy recovered. 6 weeks later, Jenner infected the boy with the smallpox virus. Wow, I don't think we would be able to do this nowadays. Like just your gardener's son. He showed no noticeable effects at all. Okay, pretty good. Jenner then repeated the experiment with 22 more people, a course of action that today would be considered gross negligence. Yes, it would, but it worked. Again, none of the inoculated subjects died or showed signs of serious illness. It was the proof Jenner needed that his method, already termed vaccination, was effective. A great controversy. Although Jenner's success was greeted with great enthusiasm, it also drew bitter opposition on scientific as well as ideological grounds. Reactionary bishops joined with enlightened philosophers, including Immanuel Kant, in opposing vaccination. The situation was complicated by poorly trained practitioners carrying out Jenner's procedure without properly understanding it, sometimes spreading the disease rather than containing it. Wow. One of the most important precautions stipulated by Jenner was that samples should only be taken from cowpox blisters 7 days after they first appeared, ensuring that the illness was less virulent. That means less severe. Although Jenner never knew it, his emphasis on a weakened strain of cowpox would later prove the key to tackling other diseases. When a relatively benign animal equivalent of a disease did not exist, it was discovered that a vaccine could be developed using weaker, related microorganisms. Jenner himself was unable to apply such thinking, as pathogens and their workings were not understood in his lifetime. His methods, however, worked extremely well and were gradually implemented throughout Europe. In 1803, the Royal Generian Society was founded in Britain, offering vaccination free of charge in a drive to tackle a disease killing 80,000 Britons every year. In 1805, Napoleon Bonaparte ordered the vaccination of his entire army. The Spanish government launched a 3-year-long philanthropic expedition to bring vaccination to the Spanish Empire and beyond, including the Americas, the Philippines, Macau, and China. Jenner wrote of this remarkable expedition, "I don't imagine the annals of history furnish an example of philanthropy so noble, so extensive as this." Interesting. So they had a mass vaccination campaign. Jenner's legacy. Edward Jenner found himself bestowed with a wealth of titles and honors. The British Parliament awarded him £10,000, a colossal sum for the time, later supplemented with an additional £20,000. Yet, despite all the glory heaped upon him, Jenner remained a man of relatively modest habits. He returned to the village of Berkeley, where he continued to practice as a doctor. It was here that his wife and one of his children succumbed to another great scourge of the time, tuberculosis. On January 25, 1823, Jenner suffered a stroke while asleep and was found dead the next morning. He was 73 years old. In 1840, the British government formally banned variolation and passed laws to vaccinate the entire population for free. Smallpox was being beaten, but one mystery remained: its cause. This was resolved when Louis Pasteur and Robert Koch discovered germs, and in doing so, made it possible to develop vaccines against other diseases. The last known case of smallpox was in Somalia in 1977. The long battle against death and disfigurement was over, thanks largely to the insight of an English country doctor. Okay. Salvation for humankind. Let's look at this. Jubilant support and poisonous opposition. Jenner's method sparked a vigorous debate. Though some immediately hailed the considerable advantages vaccination would offer to humanity, others sounded the alarm on its risk, both real and imagined. The two caricatures below gave a good idea of the starkly different responses elicited by Jenner's seminal discovery. Seminal means like just life-changing, world-changing, seminal discovery. It's a very, very important discovery. So here we have salvation for humankind. Okay, what do we have here? In the background, victims of smallpox beg for help. Jenner himself appears on the right, crowned by an angel as preserver of the human race, wielding the scalpel used to carry out vaccinations. Jenner beats off the traditional doctors, who flee bearing scalpels dripping with gore. One of the scalpels has the curse of humankind engraved on it, and at the doctor's feet lie the bodies of children killed by their refusal to act. Okay. Now here's this one. A devilish discovery. This 1802 caricature depicts Edward Jenner feeding small children into the fierce-looking jaws of a cow-like monster covered in pustules. Killed by Jenner's vaccination, dozens of dead infants are hurled by a demon into a wagon. In the background, 5 doctors opposed to vaccination descend from the Temple of Truth to join forces against what they consider a murderous practice. The Temple of Truth. Interesting. So here's some questions we can think about. This is no different, really. Well, it's a little different, but basically the same psychological rationalization. Humans still have these two opposing viewpoints. It can either be vaccinations can be good, or they can be something bad. So now in the world, we definitely have people who are anti-vaxxers, and the vaccines will never be perfect. We can see here that there were a lot of problems, and even the precursor to the vaccination was not really safe. There were a lot of risks with these things. So some questions to think about are basically, can we trust vaccinations? Should we trust vaccinations? If we look at history, have vaccines been something good? We can see that, yeah, they've been pretty good. There might be some hesitation to try it, to take a vaccine when it's new, especially with smallpox. There were some issues with the vaccine, but we can think about this idea, this way of thinking that people have when they are opposed to vaccines. They think they are evil. They think they are going to hurt people, kill people, control people. So we can think about why people get into this frame of mind, and is there any way that we can change it? Or is there any way that we can help people think maybe more clearly about how, like, the benefit of vaccines, how it can help, as people said here, preserve the human race? And then we can also try to build up the other side of the argument and say, well, okay, maybe, yes, there are problems with vaccines. We want to make their argument strong, and we can say, okay, there have been issues. Let's look at that, and let's see why maybe your idea is right. So we can think about the dichotomy here, the two different ways of thinking, and eventually then we can look towards the future and think, okay, so which way of thinking should we follow? Should we be afraid and be against vaccinations and just cancel them completely? Or should we go the other way, and should we maybe think, yeah, they can be bad, but they might, well, they probably do help us. And something that I always think about is when I watch the news and see a COVID vaccine, I think that's great. That's amazing. And it was done quickly in laboratories in a way safer environment than this stuff. But when people go on the news and they say it's 100% safe, there's no issues, it will never cause a problem, I think that's where they just need to be honest, because nothing can really be 100% certain when we're dealing with vaccinations and medicine. Not to, when it's something new like this, we can't have, when it's never been tested, we can't be completely sure that there will be no problems and it's completely safe. We have a very good understanding of it, and I think we just need to be honest with everybody and say, throughout history, there have always been issues with vaccination, but we go through these tests and we research because we are basically trying to preserve the human race. So we are trying to help everybody. It's not a nefarious process. And I think people just need to be honest and say, look, it's not perfect, but this is what we have, and we think that it's good, and it's okay if you have hesitation. We understand that. Okay, so that's something to think about.